Hello everyone, welcome back to Calculus 1000. The first day of last week. Okay, so because of that one session that I couldn't come in, we will have a bit packed schedule this week. And I have to finish substitution for definite integrals today. On Wednesday, we will work on area. And on Thursday, we will work half on area, the other half on the volume. And Friday, we will have another day of volume. So I wish I could fit a bit better my schedule into the weekdays, but it seems that this is what we have. And the good thing is that we will be able to finish it properly. Like, there shouldn't be any worry about did we cover everything or not. Before I start, is there any questions, any comments? Okay. Let me write down the substitution that we worked on. It says if you have an integral which is of that form, the integrand is a function of another function. If you have the derivative of that inner function as a factor of your whole integrand, then you can rewrite your integral in something different. You rewrite it in a new, as a new integral, but this time, well, there's no official name there, but I'll call it U integral. So you're changing your x integral into U integral. The way the thing will work is this, that gx, you're setting it to be equal to your new variable, u. And as a result of that, you have to also determine what is du. Because this new integral should have a du, and du is not necessarily equal to dx. It is g prime x dx. In other words, we need that factor of g prime x so that we can take this whole thing and replace it by dx. The rest will be just f at u. It will be a function, an integral in u. It's going to have simpler. Okay, the goal is at least that fu du will be an easier integral. Is it something that we can evaluate it? That's a story of is your substitution a good substitution or not. You have to see that there are two different things. Did I carry out the substitution correctly? Means that did I write correct u integral there? Is this a good substitution? Means that the new integral that I have, can I solve that new integral? That's the second question, which is, okay, is this a good substitution? Sometimes you may need to go back, change your substitution, carry out the full substitution, hoping that you will get an easier integral. So today we will start doing some examples. So I'll write down a few examples. And Okay. Write it down. You will get 2 minutes. 2 minutes to fix what is your function that you want to do substitution for, and carry out the substitution. In other words, I don't want you to go beyond this point. Once you change it to a new integral, just stop there, go do the other one. In other words, I am trying to do some practice for, am I choosing right gx to be my u? The second thing, am I able to carry out the substitution completely? Yeah? 2 minutes, you are doing the substitutions of these ones. I'm hoping that you will be able to do at least 2, hopefully 3. If you can do the 4 of them, that would be even better. 2 minutes to start.
It's like actually not fun. It's not even all that.
20 seconds. Okay. So when you're doing that substitution, you have to practice. Yes, you have to do almost more than anything else. You have to do just more practice, see more examples to be able to say that now I can handle the substitution. And one I will write few things. Again, this is not covering everything. I'm just giving you some clues. When you see your integral, maybe those are the starting points for you to think about. If you have a function to the power n, when you have gx to the power n, this includes more than one thing. It will, for example, include these guys, or it will include this guy in general, yes? So when you have such form of integrand in your integral, maybe, I'm not saying always this will work, but this taking gx to be your u would be the first guess for you. And most probably it will work out nicely for you. In this case, I have square root of sine x. So I'll use that fact, well, that clue to start setting up my integral, my u variable equal to sine x. And then this will tell me what is du. Du is not dx. It is derivative of sine x, which is cosine x, times dx. In other words, when you're doing the substitution, this part, you already know that this will give you square root of u. But cosine x times dx together will give us what is du. And without du, your integral, your sentence is not even complete. Let's put it that way. This is carrying out the substitution. From this point on, I'm just trying to evaluate that. That is u to the power half. And then you get 1 over half plus 1. U to the power half plus 1, which is 3 over 2, plus c. Okay? And that is 2 over 3 square root of something to the power 3 plus c. Okay? Remember, u is a temporary variable that we introduced. The final answer should not be in terms of u. It should be in terms of x, meaning that I'm not done if I leave it that way. My whole integration process missing a step. And that step is put back in the function u in terms of that gx, or a function of x that you fix at the beginning. Okay? So that hint give away a few things there. Also, if you have e to the power gx, or you have sine, any trig functions at gx, cosine gx, tan gx, secant x, gx, that is another clue that maybe you should take whatever is inside of exponential or trig functions as your substitution. So in this case, I'll take u to be 3x e to the power something, and du is, it's not dx, it is 3 dx. Wait a minute, I'm missing the 3. We discussed this shortly last time. When you fix gx, you find g prime, it's okay if you're missing a constant multiple. Only then you can fix it. If it is missing only a multiple of 3 here, you see, there is no 3 here. How do I fix it? We know that integrals are linear functional, meaning that they work nicely with constants. In other words, I can multiply the integrand by 3 and multiply the whole integral by 1 over 3. They will cancel each other, so I didn't change my integral. But by doing it, now I have my du here, and my substitution can be completed this way. That is carrying out the substitution. Is this a good substitution? Well, let's see. Oh, antiderivative of e to the power, oh, sorry. I missed that 1 over 3, so I have to bring in that 1 over 3. Antiderivative of e to the power u with respect to u is e to the power u, so I had to put plus c there always. Now I have to put back in the x function. 1/3 again? Integral of eu du is the meaning of find antiderivative. That's the notation we fixed for find antiderivative for e to the power u. Any other questions? Any other comments? In this one, you see sign of a function. So that is a right candidate to start with at least as our substitution. And then du is equal to minus there's something going on over there. If you have a question, you should ask me. Thank you. I see there's a sign of some function. That's a good candidate. Let's see if I can carry out and complete the substitution there. I set cosine x, whatever is inside sine. U equal to the function inside sine, which is cosine x. And then du, I know that is derivative of this times dx. I look at here. Oh, we have this sine x dx, but we are missing that negative sign. Again, constant multiple missing is not a big deal. I can always multiply inside of integral, multiply outside of integral by its inverse, and get rid of that, or provide that constant that you're looking for. In other words, now I have created what is my du. Well, what was the expense I paid? This constant multiple, and this is sine of u. Antiderivative of sine u with respect to u is negative cosine u, but there was a negative sign before there, so it cancels. And then the result is cosine of cosine x plus c. Any questions, any comments there? What should I take u for this integral? E to the power something. That's the good candidate. So I'll go ahead, do u is equal to root x. Du is 1 over 2 root x dx. I'm missing that 2 in the denominator. I can multiply it by 2, multiply the denominator by 2, multiply the whole integral by 2. They will cancel out. Now, what I see is this, 2 integral of e to the power root x 1 over 2 root x dx, which will give me 2 integral of e to the power u du. And again, that's another example of any questions, any comments so far? The rule of substitution. Yes, please.
Way to simplify cosine cosines.
No. Cosine x. There's nothing simpler than that. Any other questions? Any other comments?
I like this one.
Okay. What we have done so far. Yes, please. Well, I don't know to start with. I take my u, and when I differentiate it, I see that everything is there but one constant multiple. So here, in the original one, I didn't have that too. Constant multiple, I can fix it as I said. Yes, you multiply, you divide, and then you get that thing done. Yeah? Make sense? Okay. What we have done so far is substitution for indefinite integral. What should we do if we have definite integral? In other words, if you not only have an integrand, but also limits of integrals. So if you go from A to B, you not only need to change the integrand, well, that part will go as we did for the indefinite integrals. You also need to change the limits of the integral. How do we change that one? Okay, you already have everything up there. You said that the new variable is gx. And I know that the limits for x integral are lower limit is a, upper limit is b. Okay, so if x is equal to a, my u will be g at a. So my lower limit will be g at a in the u integral. Upper limit in x integral was b, then upper limit in the u integral, the new integral would be g at b. Without the change of the limits of integral, your substitution is not complete for definite integrals. You're not only changing the integrand, you also changing the limits of your integral. Let me do one simple example, and then I'll go. We will do more example, and we'll try to do more. Okay. I look at that integral. Well, there is a square root of something. That's the hint I will take. That's the clue I will use to set my substitution. U to be whatever is inside the square root. 2x plus 1. Then, when I do du, I see that, oh my God, there is a 2 that I need, but it is not present. Fixing a constant factor is easy. You just multiply. You can either multiply it there, or I'll write here and divide the whole integral by the same constant. Now, forget the limits for the second. So we have 1 over 2. That 2 and dx, 2 times dx, this recipe says that is nothing but du. Square root of 2x plus 1, I know that is nothing but the square root of u. This is not complete. It would be complete if this was an indefinite integral. I have to fix the limits of the new integral. The new integral that now I have everything waiting for my calculation to find the lower and upper limit. How do we do that? The old integral has the limits there. x0 is lower limit of x integral. That implies that u must be g at 0. 2 times 0 plus 1 is 1. Let me write it maybe. 2 times 0 plus 1, 1. What does that mean? I started with the lower limit of x integral. I plugged it into u, or gx, and I find the lower limit of u integral. So lower limit over there is 1. How about x equal to 4? That's upper limit of x integral. That will give me upper limit of u integral. which is 9. It is now done. The substitution of definite integral is not complete until you not only change the integrand to in the u integral, but also change the limits to the new limits. It could become the old limits, but we have to do the calculation and get those values in place. Now, I want to evaluate this. This is u to the power half. So it will be, there's a half out there. 1 over half plus 1, 3 over 2, u to the power 3 over 2. I am using FTC1. I have the, FTC2, Fundamental Theorem of Calculus Part 2. I have the antiderivative of my function. Now I am using the information given by Fundamental Theorem of Calculus Part 2, which says the value of that integral is you evaluated at the upper one minus evaluated at the lower one. So in this case, so this 2 cancels with that. That's 1 over 3, 9 to the power 3 over 2. Oh, my mic died. Since I'm not sure what it will do with my recording, I'll stop and change that. You hear me now? Yeah, better? Okay, I plug in the upper one minus plug in the lower one. Yeah? So 9 to the power 3 over 2, that is 9 to the power half is 3. 3 to the power 3 is 27. Minus 1 divided by 2, this value is 26 divided by 3. 27 minus 1 divided by 3. Did you notice something interesting happened there? Did anyone notice that something is different? Other than changing the limits of the integral, something also interesting happened at the end of this calculation. Bless you. Yes, please.
You didn't have to replace u with the original function. You could just plug it in straight away because the 9 and the 1 you already changed.
We are not working with indefinite integrals, so that means that at the end we are trying to find a number. If your u substitution, you can evaluate that, use the FTC2, and you find the number. You find the value of your definite integral. There is no u left there. You can leave it as is. It's not the indefinite integral when your final answer should be a function of your integral. That's why we have to change it to x function at the end. Here, it's a number. You found it. You can go ahead and leave it as is. Yes?
Explain why the 1/2 is the 1/3.
1/2 times 1 over 3 over 2. This 2 and that 2 cancel. There is a 3 in the denominator. In other words, in the denominator, I have 2 times 3 over 2, which cancel out, and then you get 3 in the denominator. Yeah? Any other questions? Any other comments? Yes, please.
For the 9, like
From 1 to 9, yes? Lower limit for x is here. So I found the antiderivative. Fundamental theorem of calculus says Fundamental theorem of calculus part 2 says if you find an antiderivative, you need to plug in your antiderivative on the at the upper one minus lower one.
But wouldn't it be
The lower one is, it's 1. I plug 1 to the power 3 over 2. There is 1/3 up front. I factor it out, yes? That's maybe, okay, yes. Any other questions, any other comments? Yes, please.
Why did you put it to the power of 9?
I didn't put it in the power of 9, no. This is power of 3 over 2, you mean? Where is the?
Oh, I see. Sorry, no.
Okay. Any other questions, any other comments? We need to do some more examples. Some more good examples. Okay, I'll write down 2 examples.
It's not as good as it's pretty close to no. The 5%.
Okay. You go ahead, please. You're trying to evaluate those 2 integrals. Well, feel free to talk to the person sitting next to you, but you will get 2 minutes again. My hope is that you're able to carry on, complete the substitution. You pick what is your g, you start writing integrand for your u integral, and change the limits, and leave it there and go to the other one. 2 minutes should be enough for that. Go ahead, please. 2 minutes starts now. No, it's cosine over sine to the power 4 of x. Yes. Yes, you're always welcome to talk to your friend, but only about the problems here.
Like clashing. No. You don't see. And then I some enemies. And then I have to say not productive to talk about what happened.
Okay. What was the substitution that you chose to carry on? For the first integral, cosine of x over sine to the power 4x. What was the good substitution to do? Yeah? Yes, please, sorry. Sine x. Can you tell us what was the clue, what was the hint that you saw there?
Wanted the cos x to cancel out.
There are two things. One is that something to the power n, yes? So this thing is here. But that is supported by the fact that the derivative of sine x is cosine x, and it is up there. So it is a factor of the numerator. So if we set u to be sine x, well, obviously that will give me cosine x dx is my du. In other words, this and that, from the numerator you take that one out, times dx will give you du. In the denominator you have u to the power 4, or in other words, you have that. But that's not enough for us, because this is definite integral. We have to change the limits. In other words, I should start, bless you, lower limit in x integral is pi over 6. That will give me what is lower limit. What is lower limit in u integral? By plugging in pi over 6 into sine x, which is half. Upper limit in x integral is pi over 2. Upper limit in u integral is going to be sine of pi over 2, which is 1. Now my substitution is complete. Before this, I could not move. I had to complete that. Now I have a definite integral in terms of u, but this is u to the power negative 4, which is, if I do the power rule for indefinite integral, that will give me antiderivative is u to the power negative 4 plus 1. 1 over negative 4 plus 1. Yeah? But this is FTC part 2, meaning that I will go from there to that. In other words, I have negative 1 over 3 u to the power negative 3, plug in 1. It will be 1 over 1 to the power 3 minus 1 over half to the power 3. And that is negative 1 over 3. This is, it comes all up. It makes it 8. This is 1. Negative 1 minus 8 is negative 7. That is plus 7 over 3. Any questions, any comments there? Are we all good there? Yeah? How do you feel? Okay. This other one. Did anyone do this one? What is the right u for this one and why? What is a good substitution part for this one? Yes, please. Ln x. If I do ln x, the derivative is 1 over x. And this will be 2 plus u, basically, yes? Or I could have taken the whole numerator as my, because that's constant, yes? So I can take 2 plus ln x. The reason that ln x should be there somehow, because the derivative is 1 over x. And we see that our integrand has this big factor of 1 over x. So we will use that fact. Du is 1 over x dx. And we see that there is 1 over x dx there. So that is du. That numerator is u. We are not done. Why? Substitution for definite integrals requires change of limits of integral as well. In other words, I have to now tell you what are the limits in my u integral. And finding that is just simple work, because lower limit in x integral is 1. Lower limit in u integral would be plugging 1 there. 2 plus ln of 1, which is 2. So my 1 in x integral changes to 2 in u integral. How about x is equal to e? Well, then u would be 2 plus ln of e. Ln of e is 1, 2 plus 1, 3. So integral limit e now changes to 3 when I'm changing my integral. There we go. We're good to go now. Because FTC now says, if you know what is an antiderivative for u with respect to u, then you're done. And we know we just need to use the power rule for integration or antiderivatives. U to the power 1 plus 1 over 1 plus 1, and we go from 2 to 3. And that is half of 3 squared minus half of 2 squared. That is 9 minus 4, which gives me 5 over 2. Any questions, any comments? Are we all doing good there? Yeah? 5 over 2 is 2.5, yes? Yes, we found 2.5 as well. Okay. Among the substitutions that we have been working with, there is one case that I want you to pay a bit. There is one case that I want you to pay more attention to that. This is when you have the derivative of function in the numerator times over the function itself. Well, this is already being covered with these guys, but I just want you to do some more examples for this. And I will just write some indefinite integrals to be able to do some of these. And one good case, which I will do that one myself, is when we want to integrate one of those nice trig functions. Integral of tan x dx. These are indefinite integral, but substitution, the main part happens there. So I'll just leave it as is. integral of tan x. I can write this as sine x over cosine x dx. Why I'm writing it that way? Because when I do that, what I see is that the derivative of the denominator is in the numerator. Well, that's a lie. I'm missing a negative 1 factor. But we know that I can always fix that by multiplying the numerator by negative sign and the whole integral by negative sign. Now, what I see is that the derivative of the denominator is in the numerator. And that means I can take u to be the denominator. du is going to be derivative of the denominator dx. And that will give me, see, negative sine x times dx is du, and that will be 1 over u. Antiderivative of 1 over u with respect to u is ln of absolute value. Oh, there's a negative sign. I have to take that 1 over. That is negative of absolute value of u plus c. Or in other words, why? Because I can bring this negative sign in, and it will become a power of b. And u to the power negative 1 is 1 over u. But then I can put in back what was my x function. And 1 over cosine x is 1 over cosine x is secant x. So antiderivative of tan x is ln of secant x, or absolute value of secant. How much time? We don't have much time left. I will leave those two for you. We are not going anywhere. You're working on these ones 30 seconds, and I believe you can complete those ones. Yes, please.
Would we also do the same thing for cotangent or the secant x?
The similar thing goes on with cotan. So in that case, you will get ln of negative ln of cosecant x. There is no generality here. We are dealing very special case there. Yeah. Yes, please. I set you to be cosine x. What's going on today? I hear so much chatting. I cannot answer the questions. I set you to be cosine x. What is du? It's not sine x dx. It's negative sine x dx. So I have to provide that negative sign somehow, yes? Do these ones yourself. U for this one is the denominator. U for this one is, again, the denominator, because the derivative of the denominator is in the numerator. That substitution will work, and both of them will change to ln of the denominator, ln of the denominator. Have a great day. See you all on Wednesday. When you come back, we will do applications of integral.